This is for Year 12 methods. It's question number 13 out of the 2014 Functions Test SAC. State all possible values for x. Okay, so I've got a quadratic equaling linear. I'm going to move these over and I'll have 4x squared minus 8x minus 4x plus 2 plus 11 equals 0. 4x squared minus 12x plus 13 equals 0. The discriminant will be b squared minus 4ac minus 12 squared minus 4 times 13, 144 minus 208. I've got a problem. There's no solution because the discriminant's negative, therefore there are no solutions for part 1. Question 2. I've got x sitting in one spot, so I'm going to do some backtracking. I'm going to move the 7 to the other side. 2x minus 3 to the 4 equals 7. I'm going to take the fourth root of both sides. 2x minus 3 equals 7 to the 1/4. 2x equals 3 plus or minus 7 to the 1/4, because I'll have two answers of taking the fourth root of 7. And x will equal a half of 3 plus or minus the fourth root of 7. And they're my two answers. In question here, that's a squint question. I can turn that into a quadratic. 6 on e to the x plus e to the x plus 1 equals 1. I'm going to let k equal e to the x. 6 on k plus k equals 1. Multiply everything by k. 6 plus k squared equals k. Move the k over. K squared minus k plus 6 equals 0. And if I was to do the quadratic formula, k equals minus b, so 1 plus or minus the square root of 1 squared minus 4 times 1 times 6 over 2. 1 plus or minus the square root of negative 23 on 2. I've got a problem. I can't take the square root of a negative number, therefore there's no solution to this question either. Okay, part 4. I've got some logarithms, base 3, base 3. I can combine these two logarithms together. However, I can't have a 2 at the front. So I'm going to have log base 3 of x squared minus log base 3 of x minus 2 equals 2. I can now combine them together. Log base 3 of x squared over x minus 2 equals 2. Since I have the one logarithm, I'm going to turn it into an exponential. X squared x minus 2 equals 3 to the power of 2, or 9. X squared equals 9 times x minus 2. X squared equals 9x minus 18. X squared minus 9x plus 18 equals 0. X minus 3 minus 6. X plus 6. X minus 3, therefore x equals 6 or 3. Both 6 or 3 both fit into the original because I have no problems with those logarithms not existing. So 6 or 3 are my answers. Over the page I have a modulus, but that modulus is around the x. So I'm going to have two separate solutions here. I'm going to have, when the modulus is positive, e to the 3x plus 1 equaling 2, or when the modulus is negative, e minus 3x minus 1 equals 2. This one will give me a solution which is 3x plus 1 equals log base e of 2, 3x equals negative 1 plus log base e of 2, and x equals negative 1 plus log base e of 2 all over 3. And this solution will give me minus 3x minus 1 equals log base e of 2, minus 3x equals 1 plus log base e of 2. X equals, it's on 3, but the negative will turn that to negative and that to negative. So I could turn this into the 1 and say I've got minus 1 plus or minus log base e of 2 all over 3 as being my two solutions. Okay, in this particular question, I'll do the same thing. I've got a logarithm, I can turn it into an exponential. So the modulus of 9x can equal e to the 1, or the modulus of 9x can equal e. I can have two possible equations, 9x equals e, or minus 9x equals e, depending on whether the inside of the modulus is negative or not. I'm solving for x. X equals e on 9, or x equals negative e on 9. I can put them together and go plus or minus e on 9 as being my two solutions. The next question, I've got a modulus again. I'll either have x squared minus 3 equal x, or x squared negative plus 3 equal x. X squared minus x minus 3 equals 0. Jumping to the quadratic formula, it gives me x equals minus b, so 1, plus or minus the square root of minus 1 squared, which is 1, minus 4 times, so plus 12 over 2, which equals 1 plus or minus root 13 over 2. And on this side, I end up with, I might throw everything to the other side, 0 equals x squared plus x minus 3. X equals minus 1 plus or minus the square root of 13 over 2. Now, I have a little problem here. My problem is, this is always positive because it's a modulus. And if this is what x equals, x must always be positive. Since x must almost be positive, then I can't accept the answer 1 minus root 13 on 2 because it's negative. And I can't accept the answer negative 1 minus root 13 on 2 because it's negative. So my solution for x in this case is 1 plus root 13 on 2, or minus 1 plus root 13 on 2, because in this particular case I couldn't accept negative values for x. In the next question, the last question. Okay, in this last question, I've got an x and I've got a square root with an x inside the square root. Even if I move that over, I'm going to have x equals 2 square root of 3 minus x. I need to get the x out of the square root. So the way I'm going to do that is I'm actually going to square both sides. If I square both sides, it's still equal. So that's x squared. That's 4, 3 minus x. 2 squared becomes 4. The square root of 3 minus x becomes 3 minus x. We've got x squared equals 12 minus 4x. Move everything over. X squared plus 4x minus 12 equals 0. I think I can crisscross that. X, 6, 2, the negative on the 2. Therefore x plus 6, x plus minus 2 equals 0. Therefore x equals negative 6 or 2. Like I did before, I need to double check and make sure that when I substitute these into here, it actually is correct. So when x equals 2, I end up with 2 over the square root of 3 minus 2, which is 2 over 1, which equals 2, and that equals 2, so that's a good answer. When x equals negative 6, I get negative 6 on top of the square root of negative 3, that's positive 3, minus 6, which is negative 6 on the square root of 9, which is negative 6 on 3, which equals negative 2. And that doesn't equal 2, so I can't accept the negative 6 as a possible solution. Therefore, 2 is the only solution.